Okay. We just talked last time about how, like, if a bug was moving through the water, it could be a boat moving through the water. As it speeds through, if it's going slower than the speed of the waves, then they will get closer together in front and farther apart and back, and that gives you high-pitched waves or high-frequency waves in front, low-frequency in back. That would be like the Doppler effect. Now, if it goes to where your speed equals it, you end up with this bow wave or a shock wave, if you will, up here in the front where all these are compressed together because all the edges of the leading wave would be together. But if you actually start going faster than your sound waves, then you start getting overlapping circles in this sense, and where they overlap is on the edge, and you get this V shape here. Okay, and that would be kind of like the shock wave. Now, if you go, and the faster you go, if you go even more faster, you get even a more long, skinnier cone of shock waves. Okay, and so someone said, well, how does that apply to sound? Well, good news is, I guess, most things cannot go faster than the speed of sound. That was the big deal. Supersonic jets were the first to do that, and so it was to go faster than sound. Okay, and basically, you use the same kind of overlapping thing, but instead of overlapping waves here, you have compressed air. So it's getting very compressed right there. And so what happens as the airplane is going through, you get two cones, if you will. One from the front, which is the where these kind of the equivalent of this sonic shock wave here on the front, or the bow wave we talked about with the other one with water. This V shape, that's very high pressure air. So you've got regular air pressure air. Then when you hit this part right here, this V part, that's this V here where it's high pressure. It's being compressed tightly together because these overlapping air waves. Okay, and then as you go back here, it gets less and less until you get very low pressure air. Back here at the backs, they're so far apart, and they're in between the next one, that it's very low pressure air. So the pressure goes up really high when you hit this leading edge, then it drops very quickly to even lower than normal air pressure, and then it pops back up to regular air pressure once the plane and the two cones of pressure have passed by. And so you have this change from high pressure going to really low pressure and back to normal pressure again. And when the differences in that, you hear that, and the hearing that is basically a sonic boom. When you hear a sonic boom, and when you hear a sonic boom, if you look straight up, you're not going to see the plane because it's already going. In fact, because it's going faster than the speed of sound, it may be far off, just barely on the horizon, or even off the horizon where you can't even see it yet, depending on how good visibility you have where you're at, because it is going so fast that by the time you don't hear it when this plane is right over above, you don't hear it until it's past you, and then this cone of pressure that spreads out from it. Another picture of it is this one here. Kind of shows a little bit better picture of it, but you can see not only is it, you see the V shape, but actually it's circular and spreads out in all directions from there. And so by the time you're in this area here, or especially if you're over here on the sides, by the time you hear this sonic boom, this may be so far apart, the plane may be so far away that you may not even see it on the horizon yet. And so a sonic boom is caused by airplanes that go faster than the speed of sound, and because they're going faster than the speed of sound, they're causing these overlapping waves, the overlapping spots, to make like a ridge or a cone, if you will, of high pressure air, which drops to very low pressure air before it goes back to regular pressure air. And those changes in air pressure are what makes the booming sound that you hear. So the question could be asked, what about a regular jet? Well, when a regular jet or even an airline or something like that, airliner is going overhead, they're not going faster than the speed of sound. Okay, and since they are, you never get this cone of pressure in the front, and therefore you do not get sonic boom. But for example, a lot of Air Force pilots and stuff like that, some of those jets are supersonic, and they would go fast enough to give you that. Now, to visualize it again, this is a shock wave of a bullet that has passed through plexiglass. They hit plexiglass. When it did that, that sent shock waves out, sound waves, and since it's going faster, you can see this area of high pressure in front of it, okay, because the bullet is traveling faster than the sound waves. So you have this high pressure, and you can almost make out kind of a V coming off the back end, and so that's that cone right there. And the changes in pressure here is what would make the really loud noise of it going through the plexiglass. And the same kind of thing is happening with just sound waves, except for now your bullet or fast traveling thing would be your airplane, and you get this high and low pressure below it, and that's what causes a sonic boom and causes all that kind of problem. And I think we finally are done with all of the sound videos.